Today we are going to see the full wave rectifier circuit and the practical experiment, and we will see that how the output voltage is varying with the change in the firing angle. For this we have taken a resistive load and inductive load. This is the resistive load that we have taken. We are using a variable resistance, so this is nearly 94 ohms, and here we have taken an inductor, the primary side of a transformer, and the value is nearly 30 ohms is the resistance, and inductance we need to calculate. So this resistance and the inductance are connected in series in the output. In this modulator, single phase fully controlled converter power circuit, we have a thyristor T1, T2, T1, T1 dash, T2 and T2 dash. And the firing circuit is being given through the single phase converter firing unit. Now you can see it is off and 0 degree. And we are giving the supply to this single phase controlled firing circuit by L and N, phase and neutral, from this transformer, and this transformer primary is connected from the supply, that is 230 volt, and we step it down to 0 to 24 volts, where RMS value is 24 volt, that you can see in this multimeter, 24 volts. So this 24 volt is given to the line and neutral here, and we are getting the output 0 voltage and 0 current, and in the CRO we are not getting any reading because the output is 0. And now we are going to trigger the firing angle, giving the pulse. We put it on, and now it is changing from 180 and gradually it is going towards the 0. You can see that now it is fired and it is changing from 180 degree, that is at the lowest output voltage, to it is going to the 0 degree, that is the highest output voltage. Now you can see that here the output voltage is gradually changing. This is 2 volt and the current is in sequence like 3, this is 0.05, and gradually you will find that this voltage is increasing and the current is also increasing. And this increase is actually non-linear with respect to the firing angle. So now we can see here in the CRO, the output voltage, this is at firing angle, seems to be at 0 degree. So now our triggering angle has been at 0 degree, and we are getting an uncontrolled rectifier or a output fully controlled output rectifier with firing angle alpha equals to 0 degree. Now here I am going to change the value of alpha and increase this alpha to some value like 30 degree. Let us increase this value of alpha to 30 degree, and then we will use the other calculation. At firing angle of 30 degree, we get the output voltage now at 15 volt and the current is 0.21 ampere, and the output waveform, it looks, this is perfectly, it is clear. Output voltage is trimmed to 0 to 30 degree, and after 30 degree it is getting output voltage. We can get that there is a negative voltage over also there because we are not using the freewheeling diode. That is why we are getting this type of output voltage waveform. Now the alpha firing angle we will again change to some higher value. So let me change this alpha to a higher value, let us say 45 degree. So I have changed the alpha to 45 degree, and obviously the output voltage will decrease, that is 12 volt, and the current is 0.17 ampere, 0.16. So that is ampere, and here we are getting this type of output voltage waveform. So it is 0 to 45 degree, it is off, so we are getting negative voltage, and then we are getting a rectifier output with negative voltage. So average voltage decreases here. Now again, we want to change this firing angle alpha a little bit more. Let us say 60 degree. Remember that we are not using any freewheeling diode. So this is the output voltage and the current. Please be there only, output voltage and current. And this is the value is decreased because the average value is decreasing. Now we can see the CRO. Let us, I am scaling it down because we are getting the output voltage, a lot of negative voltage also we are getting. So kindly just focus on this one. So it is At 60 degree, the negative voltage is very high, so that is why we are getting this type of waveforms, which we are not able to record. Like we're not able. This is not very clear. So this is a practical where we are getting lot of negative voltage and oscillations in the output, and because of the circuit R and C, internal inductance and capacitance, there is a lot of oscillations. I am now increasing the firing angle. Please connect with this CRO only. I am increasing the firing angle from 60 degree to higher value. You can find in the output there is a lot of oscillations over there. Now the firing angle is 90 degree. So I am keeping it 90 degree. You can find the output voltage waveform has totally got distorted. Let me make it a little bit higher, like 100. 100 firing angle is 100. See, the voltage is only 2 volts and the current is 0.02 ampere, and here we are getting a lot of negative spikes, and a lot of these oscillations are there. A lot of negative oscillations are there. This oscillation is because of the circuit internal resistance and internal capacitance and inductance. Okay, thank you very much. Thank you.